Hey everyone, it's Nick, and I am back with the Indigo Philadelphia Public Bikes dataset, and we're going to do a Power BI, just a little walkthrough. We've already been doing quite a bit in this. Made a map. We're calculating some distances, and last time we used this, uh, used our sort of our flat earther distance. This makes no, I mean, it makes some sense, and as we'll see, it correlates well with the real distance. And if you're just doing if you're doing fast math, that's fine. But I think this time we'll try and actually calculate this properly. And then also see how it correlates, because right now this is, we look at this. We tried to see if there's a relationship here between the distance to the center on our x-axis, um, and then the number of bikes, or number of docks at a station. And it does look like we have some smaller stations farther out, but otherwise we have some pretty well. Um, oh, it's really hard to really suss out any relationship, anything on any of these that are closer. Um, so, but I'm gonna still, this bothers me. This distance to center being not in understandable units. I'm used to meters or kilometers, or probably more like miles, since I'm an American. But I did just get back from vacation in Croatia, which was awesome. I definitely recommend going there. Um, so, uh, sorry, I just had a flashback to some delicious cevapi in Bosnia and Herzegovina. But all right, we are going to calculate a different distance, and in this one, I got to give a shout out to uh, this Trancy Lee, who wrote this article a couple of years ago. There's lots of different folks who have put some definitions, or calculations of how to account for the world's the world's curvature. So in doing your Power BI in distance calculation. So we are going to use that. And her calculation is actually more complicated, because I think she's calculating between two tables. So, but I am going to take that, and I'm going to make a new distance, um, distance variable here. And I'm going to say in kilometers index. So pressing Alt and Enter, because we are going to make some variables. Oops, and did some hotkey work, which is cool. I probably need to do more of that. So she has, yeah, min from and to tables. That's not what we're doing. So in this case, we'll make our point one is just our latitude for each bike station, and our point and longitude as well. So longitude. And now our point two will always be our center. Um, so that's our median latitude. And remember, we used we used the um, all function in DAX to recalculate the context. Oop, look, I got a little comment in here. So return final. This is not my own. This is not the way I would do my own DAX exactly, but that's fine. And what do we have? What's our issue here? Uh, let's see, didn't close that out. How did I copy this over incorrectly? Did you catch it? Can you let me know? Um, oh, that was not an actual minus. It was a large dash or something. Okay, so now we should have distance to center in kilometers coming up here and being calculated. And let's see here, see if this makes sense. Philadelphia it's big. It's a big city, but it's not that huge. So none of these should be maybe approaching 100 kilometers at far away. But I think we're probably looking at uh, closer to 80 or 60 kilometers from the center. So I am going to put, yeah, I'll actually just put this as a tooltip here. I don't want the sum, want the median for each of these dots, the median distance, because each of these, again, each of these stations has multiple dock points in our table. And let's come out to Myon Bridge, median distance to center. Oh, it's not showing our distance to center in kilometers yet because it's still loading. Maybe I'll put it on a simpler values are mismatched. I will just replace our x-axis here. Oh, wow. Oh, gosh. Now I'm embarrassed. 10 kilometers. Well, I guess we're talking about biking. So our farthest one is almost 10 kilometers out. And so now I can breathe easy because clearly I didn't have an understanding of what we were looking at here. That I forgot that a lot of these bike systems don't, they're not spanning that far. And then this is going to be sort of a trivial example. We're not going to learn a ton from this, but I want to show that despite our first flat Earth like Cartesian coordinates definition, we are still. What have we done here? What did we use? Was it ID? We'll use name. We'll show that these correlate really, really, really closely. And we weren't crazy for doing this. So legend, dip, dip, dip. Yeah. And it does look like, okay, there is something systematic about the error, because we would expect this to just be a complete straight line. So systematic about the error of my of my first calculation. But what a cool looking plot, even though it's silly, all the different colors, but still, it's kind of fun and beautiful. And that's how a lot of us start getting interested in data work anyways. Okay. So just wanted to show that our first one was was directionally accurate, but not great. But now we have our new distance calculated in kilometers. And let's see, let's also replace this here just because I'm usually pretty hesitant to. Oh, so if we want to update this color, I'm hesitant to take out measures and stuff because you never know when they're going to be useful. Oh, in this case, this our new measure, which I'll throw up on the screen again, or our new column here is a lot more should be probably used every time. I'm not sure when we would go back and show the Cartesian distance. So we're looking in kilometers here. We're going to come to change the labels here. We'll go to bubbles, colors in the visual tab. And then instead of distance to center, we're going to go distance to center kilometers. And we will do the median. And it looks basically the same. But still, what a wonderful, wonderful map we have. What a happy little map of Philadelphia and its bike system.